Welcome. Here we're going to solve two-step equations, which are just a little more complicated than the simple one-step equations that we've done previously. So we're going to begin with this following example. 2x plus 5 plus 4x equals 17. So what this problem, first I had to do some simplification. So I need to combine like terms. So I have some x terms here, 2x and 4x, and then I also just have just a plain number term. But the x terms can be combined. So 2x's plus 4x's, that gives me 6 total. At this point, I'm not doing anything to the left and right hand sides. I'm just simplifying the left hand side to make my solving more easy. Okay, so now I have something that looks a little bit more familiar. I have a single number multiplied by x plus 5 equals 17. Now, we need to solve this equation. Our goal is to isolate x, is to get him all by himself on one side of the equation. And in order to do this, I will start as far away, I will look at the left-hand side where x is, and I'll start as far away from that as possible. So the term that is furthest away from x, the thing that is furthest away from x, is this 5. It's being added, so in order to eliminate it, in order to get x by itself, I'm going to subtract 5. Remember that solving equations is like raising children. Whatever you do to one side, you have to do to the other side. So we need to be fair. We need to do the same thing to both sides of the equation. Because if I subtract 5 from one side and I don't do it from the other side, I've changed my equality. I've changed my value. Okay, so 5 minus 5 goes to 0. 17 minus 5 is 12. So I end up with 6x equals 12. Now, I have my x here, and it's being multiplied by a 6. In order to get rid of it, I need to do the opposite of multiplication, which will be division. And of course, I have to do the same thing to both sides. So 6 divided by 6, anything divided by itself is 1. So I have 1 times x. Well, I can rewrite that as just x. Whenever the coefficient is 1, we don't include it. We just write it as x. And then 12 divided by 6 is 2. So this is my answer. Let's go ahead and check our work. This is a way to maximize our partial credit on exams, but also it's good practice. So I'm going to take this number 2, and I'm going to plug it into my original equation everywhere I have an x to see if the left-hand side is equal to the right-hand side. So 2 times 2 plus 5 plus 4 times 2 equals 17. Here's where order of operations are going to come in handy because I do need to do my multiplication first. 2 times 2 is 4. I'll just have the plus 5 there. And then 4 times 2 is 8. 4 plus 5 is 9. 9 plus 8 is 17. So I did get the correct final answer. The left-hand side does equal the right-hand side for the specific case that x is equal to 2. Let's do another example. Here, I'm going to consider a problem that can be solved in 2 different ways, and we're going to show both. So the example here is -3 times y minus 4 equals 36. So the first way to solve this, I'm going to make 2 columns here, and we'll solve it 2 ways. The first way to solve it is to distribute the -3 into this parentheses in order to simplify the left-hand side before I proceed. So -3 times y is -3y. -3 times -4 is positive 12. And then my right-hand side stays the same. So I haven't changed anything. I just changed the way the left-hand side looks. And I've done that by distributing the 3. So I didn't change its value. I just changed its form. Now I have an equation that looks more familiar. Again, I want to isolate my variable, which in this case is y. So I'll start as far away from it as I can, still, of course, being on the left-hand side. So I have this 12. So I'm going to subtract 12 from both sides. and I end up with negative 3y equals 36 minus 12 is 24. Now I need to isolate y, so I need to divide by negative 3 on both sides. And I end up with y, because negative 3 divided by negative 3 is 1, so I end up with y only on the left-hand side, and then 24 divided by negative 3 is negative 8. Let's go ahead and check. So I'm taking this negative 8 and I'm replacing it for y in my original equation. So I have negative 3 times negative 8 minus 4 equals 36. Here again is where PEMDAS come in handy. We need to handle what's inside the parentheses first. So I have negative 3. Negative 8 minus 4 is negative 12. And that's still equal to 36 on the right-hand side. And then negative 3 times negative 12. Two wrongs don't make a right, but two negatives do make a positive. So that becomes a positive 36. And I have checked that that is in fact correct. So the left-hand side equals the right-hand side for the specific case that y equals negative 8. That's the first way of solving this problem. The second way of solving this problem is to, instead of distributing, so I'll rewrite the problem here. I have negative 3 times y minus 4 equals 36. Instead of distributing this negative 3, I can look at this problem and say, okay, well, I need y by itself. Starting further away from it, I'm looking outside the parentheses that says negative 3. It's being multiplied. Negative 3 times, open parentheses, y minus 4. So because it's being multiplied, I can actually divide this side by negative 3 and then divide the left-hand side also by negative 3. So instead of distributing, I go straight to the solving. Negative 3 divided by negative 3, that becomes 1. So what I'm left with on the right-hand side is y minus 4. And then 36 divided by negative 3, that's negative 12. Now, on the left-hand side, I have these parentheses, but they're not really doing anything for me because nothing is being multiplied or added outside the parentheses. And when that is the case, you can drop them. So it's important in this class to know when you can drop your parentheses. And it's when there's nothing else happening. It's when the parentheses is the whole thing. And it is, in this case. The parentheses are the whole left side. So I can drop that and just have y equals negative 4 equals negative 12. Or sorry, y minus negative 4. Now I have to solve this. So I have a minus 4. I can add 4 to both sides. I'm left with y only on the left-hand side. And on the right-hand side, negative 12 plus 4 becomes negative 8. And that is the same thing that I got solving the other way. So there's often more than one way to solve equations. We just need to be clear and sure that we're doing all the steps properly and then we're not kind of breaking anything. Let's do one more example because these do get, some of them can get complex. I just want to cover one more type of example with you. So let's consider 5x minus, open parentheses, 2x minus 3. Okay, and this is, equal to 27. So the problem with this, and the reason I wanted to cover it, is that a lot of students get tripped up with what to do with this negative because there's no coefficient here. If I gave you a number here, say 4, then they would know that it's negative 4, and then you distribute that. But when it's just the negative sign, some students get a little bit tripped up on that. We can treat this as kind of a negative 1. And I can distribute it inside the parentheses in order to simplify this equation. And I should. In my previous example, I only had a number outside the parentheses, so I could solve either way. But here I have a 5x outside the parentheses, and then I have a 2x inside. So I need to somehow undo my parentheses so that I can add my x terms together, so I can add my like terms. So knowing when you're allowed to do things and not, it is important. The previous example, it was just a number, so I could divide over to the left-hand side. To the right-hand side. Here, I can't just divide or do something. I need to be able to combine everything together, which means I need to undo this parentheses. And the way we undo parentheses is by distributing. So 5x stays the same. negative 1 times times positive 2x. That becomes minus 2x. Negative 1 times negative 3. Again, 2 wrongs don't make a right, but 2 negatives do make a positive. That becomes positive 3. And the right-hand side, the 27, stays the same. Now I'm in business because my parentheses is gone, and I can add my like terms. So 5x minus 2x is 3x. I still have my plus 3, and I still have my 27 on the right-hand side. I can subtract 3 from both sides, and I end up with 3x equals 27 minus 3 is 24. Then I divide by 3 on both sides, and I end up with x equals 8. So that is my answer. We'll do the check one more time. I am plugging this number 8 in everywhere I have an x in my original function or my original equation. So I have 5 times 8 minus 2 times 8 minus 3 equals 27. All right, so again, we're going to do order of operations. I will begin inside my parentheses. So I'm just going to leave this out here, 5 times 8 minus, okay, so inside my parentheses, I have a multiplication and a subtraction. So 2 times 8 is 16 minus 3. That still equals 27. So I have 5 times 8 minus, okay, 16 minus 3, that is 13. Equals 27. And then 5 times 8, that's 40. So now that I've done this, 16 minus 3, I can actually drop these parentheses because there's nothing inside there except a single number. So now I can drop my parentheses. So I have 40 minus 13 equals 27, and that is in fact true. 40 minus 13 is 27. So my left-hand side and my right-hand side are equal. Check. And I usually just put a check mark next to it. Thank you so much for watching. Please have a wonderful day.